geometric proofs, and in this case we're talking about line segment proofs. And to save a little bit of time, I've already written down the information. Feel free to push pause and as we're going through to look at it. So again, given B is between A and D, so B is between A and D, and C is also between A and D. C is between A and D, and then what we're trying to prove is AB plus BD is equal to AC plus CD. So we want to prove that that is true. And so that's the first step right there, is write out the given, which we have done. We've written out the given right there. And then the second step is write what we're trying to prove. And that's written right there. AB plus BD equals AC plus CD. And then step number 3 is write the drawing, but we already have the drawing provided for us. So the next step, we have segment addition, and we can say AB, which is that red right there, AB plus BD, that's that blue, is equal to AD, that entire distance. And that's just the segment addition postulate. Now we can say AC, so the dark blue here, AC plus CD is equal to AD, which is that purple, that whole distance there. And that is also segment addition. Now, by the symmetric property, all I did was I rewrote this. So I said AD is equal to AC plus CD. I just switched the order of this. So AD is now starting out instead of finishing there. So that's the symmetric property where you just switch it. And if you notice here, they're both equal to AD. So in step 2 and 3, they're both equal to AD. So AB plus BD is equal to AD, and AC plus CD is also equal to AD. So now we can use substitution or the transitive property. Either one works, and we can take our AD out right here, and we can replace it with AC plus CD, which is what we have there. And then actually what we did was we took that one that we flipped, so we still have AC plus CD written there. And then we took the AD part, which we already had written there. We took that out and replaced it with AB plus BD. And the way that we did that was substitution, QED. We have started and proven that one. Again, we just want to go through the steps. So write down what's given. AM is equal to NC. So AM is equal to NC. And MB is equal to DN. MB is equal to DN. That was given. And then we're going to write down the prove. Line segment DC is congruent to line segment AB. That was the given information. And then on the drawing, I'm just going to put what was there. So we said AM is equal to NC, so two marks and 2 marks. And MB is equal to DN, so 3 marks and 3 marks. So step number 1, the given. Step number 2, the prove. Step number 3, the drawing. And now we can work on our information here. So here we said we wanted to see, again, we're talking about AB in DC. So we want that equal to. So AB is equal to AM plus MB is equal to the whole thing. That makes sense. Now, if we're looking at DC, DC is equal to NC plus DN. So that makes sense. And those are both by segment addition postulate. And now the next part is, again, we're going to talk about AB, but we want to make it look like DC here. So we know that AM is equal to NC. So what we can do is we can replace that AM with NC. And that's what we did right there. Next, we know that MB is equal to DN, so we can substitute the MB. We take the MB out and we can replace it with DN, and that's exactly what we did now. So now we have two of the exact same things. We have NC plus DN and NC plus DN. And that one is equal to DC and the other one is equal to AB. So now we have this equation at the bottom where we have AB is equal to NC plus DN, but also DC is equal to NC plus DN. So we can take that NC plus DN out and replace it with DC. And that's the substitution property of equality. You can also put the transitive property there. And then the last step is, because we weren't talking about equals, we were talking about congruence. So we want to talk about the shape. So if distances are equal, then their line segments are congruent. So line segment DC is congruent to line segment AB. And that is the definition of congruent segments. QED, our proof is complete.